Homeschool. We are again with metals and non-metals chapter. And in the last video, we discussed about the extraction of metals with moderate reactivity, isn't it? And where we have also studied about aluminothermite process, which is a very important reaction to be remembered for examination point of view. And also we studied the differences between calcination and roasting, isn't it? And if you want a description about all the videos, you can go to a description box where you will find the links of all the videos. You can refer it. Today, we are going to study the extraction of metals with high reactivity. We discussed extraction of metal with low reactivity, extraction of metal with moderate reactivity, and now we will have to discuss the extraction of metal with high reactivity. And we all know which metals are highly reactive, isn't it? The metals which are placed in the topmost place of activity series. So which metals come in the topmost position of activity series? Potassium, sodium, magnesium and aluminium. So here we are taking an example of sodium. Extracting sodium from molten NaCl. What do you mean by molten NaCl? Without using water, you are converting that solid NaCl into liquid NaCl. Okay, so how do you convert without adding water? Just by heating, isn't it? So you are taking NaCl in one vessel. When you start heating it, automatically it becomes a liquid. Okay, it becomes a liquid, and that particular NaCl, we are calling it as molten NaCl. Okay, so there is a difference between aqueous NaCl solution and molten NaCl solution. Aqueous NaCl solution in the sense making NaCl, solid NaCl into liquid with the help of water. Salt, when you put it in a water and stir it, it becomes NaCl solution. It has become liquid. How? But with the help of water. That is aqueous. Okay, but this one is molten. We are not adding any water here. But NaCl is there in the form of a liquid. How? By heating. Okay. And now this particular extraction we are calling it as electrolytic reduction, because we are going to extract sodium from molten NaCl with the help of electricity. Okay. So we are doing extraction. We are doing extraction with the help of electricity. That is the reason it is called electrolytic reduction. Okay. So whenever you are using electricity for a particular reaction, a completely different setup you should imagine. Okay, where you will have a big tank, which we will call it as electrolytic tank. Okay, this is one particular vessel, and where I will introduce two electrodes. Electrodes are nothing but metal rods, okay, where one rod is connected to a negative terminal of battery, another rod is connected to a positive terminal of battery. Okay, this is one metal rod, this is another metal rod. This rod is connected to a negative terminal of battery, and this rod is connected to a positive terminal of battery. Okay. So this is the source of electricity. Battery is the source of electricity. Our electricity will pass from like this, electrons will be passing from negative terminal. Okay. And these electrodes, we are dipping it in molten NaCl solution. Okay. So here you have NaCl. Which NaCl? Molten NaCl you have. Okay. And the moment NaCl has become liquid, we all very well know that this particular NaCl have split up into Na plus ion and Cl minus ion. Yes or no? Okay. So as long as NaCl is there in a solid form, you will not find any ions. But once it has become a liquid, you add water or you don't add water to make a liquid, right? The liquid NaCl definitely contains ions. Sodium plus ion you have and Cl minus ion you have. Okay, and these ions keep floating, keep moving. Yes or no? That is how they will carry electric current from one place to another place. Right? Fine. And now, once the ions are formed, the positive ion will go towards cathode. Okay, and the negative ion will go towards anode. Okay, cathode is what? Negative rod. Ion, sodium ion has which charge? Positive charge. Always there will be an attraction between positive and negative, isn't it? So the positive ion always goes to cathode. Remember, positive ion, that is our Na plus ion goes towards cathode. Okay. Why cathode? Because cathode is negative point, negative terminal. Okay, and negative ion, which is a negative ion here? Cl minus. Where does it go? It goes towards anode. Okay, and there they will undergo chemical reaction. You know how they will undergo chemical reaction? Let us see what will happen at cathode. At cathode, let us see what chemical reaction is taking place. Okay, this guy is going towards cathode now, and you see cathode is connected to the negative terminal. In the negative point, you will be having lots of electrons. This rod is rich with electrons. Electrons will be flowing in this direction from negative terminal onwards. Okay, so the rod is rich in electrons. Yeah, so our Na plus is moving towards the rod, and the rod is having so many electrons. You know, our Na plus ion will gain one electron here, and it will become a neutral sodium. Yes or no? So when I explained the formation of ionic compound, you have observed one thing. Sodium is there. What is its electronic configuration? 1s2, atomic number 11, right? Electronic configuration 1s2, 2s2, 2p6, isn't it? 3s1. Okay, that means 2, 8, 1. Right? This is our electronic configuration. Okay, so during a chemical reaction, what this sodium will do? It will lose one electron to occupy the electronic configuration of noble gas, and you will get Na plus. Okay, so what is Na plus's electronic configuration? 2, 8. Okay, and here the ion is getting converted into sodium. How the ion is getting converted into neutral sodium? By gaining one electron. Yes or no? Yes. So here opposite process I am showing you. That's it. Na plus is there. It is there in a solution. The guy is going to the rod. In the rod you have electrons. Say the guy is gaining one electron. It can accept electron and it can become neutral. This process can also happen. Okay. Anyway, you are not. This guy is not stable. From stability to instability. That way the reaction is moving. Okay. But such reactions can happen only in presence of electricity normally. Okay, clear everybody? So you shouldn't get confused between this and this. This concept you will observe during formation of ionic compound. Okay, so how a compound is formed from sodium? Sodium gets converted into Na plus first by losing electron. Later this Na plus combines with Cl minus, you will get NaCl. That's a different concept. And here it is a different concept. Don't get connected to this and get confused. Okay, so here in the solution you have Na plus ion. Okay, and that Na plus naturally because of the charge attraction it is going to the cathode, and the cathode rod is full with electrons. It has the ability to accept one electron, no? Yes, so definitely it will accept one electron. On accepting its electron, your sodium is back with its original electronic configuration. Okay, what was the electronic configuration of Na plus? 2, 8, isn't it? What is the electronic after gaining one electron? 2, 8, 1, which is nothing but its original electronic configuration. Okay, so you are getting your pure Na. Yes, that is our target, no? What we have to extract? We want to extract Na from NaCl solution. We got our pure Na. Okay, so all our Na plus ions will go to the rod. There they will gain one electron and it will be deposited as Na. Here in this rod you will find a white color substance getting deposited. That is nothing but the Na. Okay, how this Na got deposited? By this reaction. All NAs have moved to the rod. There each Na plus has got one electron. It will become neutral metal and that one will get deposited here. If you want Na, off it, take out the connection, bring out the rod and collect all the material that is deposited on the rod, and that will be your pure Na. Okay, and this is how you have actually separated Cl from NaCl. Okay, this is what the reaction that can happen at cathode. Now what will happen at anode? That is not necessary, but still we will see. We got whatever we want, we got. We want sodium to be extracted from NaCl, yes, we got. Okay, and let us learn what is happening at anode also. Okay, and who is going to the anode? Cl minus is going to the anode. Okay, and there, you know, this guy will lose its electron. This rod is rich with electrons, whereas this rod is deficient of electron. Okay, so, and you know, minus charge in the sense electron only, minus in the sense electron only. Okay, this guy will lose its electron and you know it will become Cl. And if you take 2Cl minus 2Cl, you will get 2 electrons you will get. Okay, 2 electrons you will get, and 2 Cl's later they will combine and you will get that as Cl2 gas. Okay, from this rod the Cl2 gas always comes outside. Here everybody? Okay. Anyway, this is not that very important, but you need to remember what is happening at a cathode. So where is your metal getting collected? Your metal is getting collected at cathode. How it is getting collected? You know, by reduction. Addition of electrons is called reduction. Okay, whenever electron is added to something, then also it can be called as reduction. Reduction has one more meaning. Addition of electron is also called as reduction. Okay, reduction. What do you mean by reduction? Addition of electrons. Okay, that is the reason this method is called electrolytic reduction. We are performing a reduction reaction with the help of electricity. That is the reason electrolytic reduction. Okay, and this is what happens at cathode, and at anode who is coming out? Cl2 gas is coming out. Cl minuses are going there. There the guys are losing the electrons, and you know 2 Cl's will combine and it will come out as Cl2 gas. And you can observe this very much clearly in the visual that I am going to show you now.
Hello children, so this is a visual on extraction of sodium from sodium chloride. Okay, see usually the moment you take sodium chloride liquid, the moment solid NaCl becomes a liquid NaCl, this is how it will break up into ions, isn't it? Na plus ions are there, Cl minus ions are there, and they are haphazardly moving in a liquid, right? Here and there they keep moving. Randomly they are present. Okay, and the moment electrons are passed, see this is a negative rod, we call cathode because this is connected to negative terminal of a battery. This is a battery, this is a negative point, this is a positive point. This rod is connected to a negative terminal, so it is called cathode. This rod is connected to a positive terminal, this is called anode. Okay, small line indicates negative terminal, big line indicates positive terminal. Okay, and now the electricity will be passed. See, electrons are moving from this rod. You can observe in a visual. I'll play now. Electrons will move, you know, it will move, and this rod will be rich with electrons. Okay, so all Na plus guys will go towards cathode, taking the electron there, it will be deposited as sodium. Okay, and all Cl minus guys, they are moving to the anode because anode is a positive guy, no? So all Cl minuses are moving to the anode. 2 Cl's will move together. That also you can observe. Okay, so what you have to observe is all Na pluses are going to the cathode, there it is getting deposited, and all Cl minuses are going to the anode, there Cl2 will be formed and it will come out. Okay, so I'll play the visual, just you can observe. See how they are moving. See all NAs. See Na plus has become Na now. Na plus has become Na now, isn't it? Observe this. See, Na plus has become Na now, Cl minus has become Cl, right? That means here Na plus gained electrons. See, these black dots are nothing but electrons. Na pluses have taken up electrons. That also you can see it in a visual. See, Na plus has taken electron, dots are there in Na. They have become neutral and deposited here. Okay, so this is how Na is extracted from NaCl. So far we studied about the extractions, isn't it? We have extracted metal with low reactivity, extracted metal with medium reactivity, and also extracted metal with high reactivity. Just now we have seen with the help of electricity we extracted a metal with high reactivity. And after the extraction, whatever we get a metal, we call it as crude metal. So what is that metal called? Crude metal. Okay, that means it is not 100% pure. There will be some impurities in it, where those impurities have to be removed, I told, and it can be removed with the help of so many chemical methods. Among all the chemical methods, one of the method we are learning, that is called electrolytic refining. And the whole process, like removing the impurities, is nothing but purification. So the purification of crude metal after extraction is called refining. What is the technique we say? Refining technique. Okay, so there are so many refining techniques. Under so many refining techniques, one famous refining technique we are studying, that is electrolytic refining. Okay, so this particular electrolytic refining, we will use, this particular method is used for purification of metals like copper, okay, silver, gold, zinc, lead, etc. Okay, so with the help of electricity, we are trying to remove all the impurities present in a crude metal that we are getting after extraction. Okay, and let us see how we do this electrolytic refining by taking an example of copper. Okay, imagine we extracted copper. Yes, step number 1 concentration, step number 2 roasting. Extraction of copper also you have seen in the video where I explained extraction of metals with low reactivity. So after extraction we got a copper, I told you, which is not 100% pure, where it should be purified. So for the purification purpose, I have used this electrolytic refining. Okay, we are doing this electrolytic refining. See how does the electrolytic refining is carried over, is something like this. With the help of electricity we are doing this. And the moment, whenever you use electricity, you know, we will have that setup, cathode, anode, electrolytic tank, electrolyte we will take. Okay, so that setup is common. So we are taking a tank where the tank is filled with electrolyte. Here the electrolyte I am taking is copper sulfate. Okay, so what do you mean by electrolyte? What do you mean by electrolyte? Electrolyte is the one which can produce ions the moment you put it in water. Okay, so electrolyte is the substance that gives ions in water. Okay, so copper sulfate I dissolved in water, I am taking it in a tank. Since it is giving ions in a water, I will call that solution as electrolyte. Okay, fine. And I am taking 2 rods here, and this is a pure copper rod. Okay, and another rod, this is actually impure copper rod. That is the metal that you have extracted, no? I told you it's not 100% pure, so many impurities are there. So that metal only we are making in the form of a rod and we are taking it here. Okay, so this is a impure copper rod and this is a pure copper rod. Definitely for this method, pure copper rod you have to use to purify the copper. And the pure copper rod is connected to a negative terminal of battery and impure copper rod is connected to a positive terminal of battery. Okay, that means this rod is acting as anode and this rod is acting as cathode. Okay, so this is anode and this guy is cathode. Cathode is connected to negative terminal of battery and anode is connected to positive terminal of battery. Clear? Setup you must carefully understand. This is very important. So in the examination they will ask you which rod is considered as cathode and which rod is considered as anode. As anode we are taking impure copper rod. As cathode we have taken pure copper rod. Okay, and the moment I pass electricity, what will happen? All the pure copper atoms present in this rod, there is definitely some pure copper, no? Impurities are there. But whatever copper atoms are there, all these copper atoms will come out in the solution as Cu plus 2. Okay? So whatever copper atoms are there, it will come out into the electrolytic solution as Cu plus 2 ion. As which ion? Cu plus 2 ion. Okay. Later, this Cu plus 2 ion, whichever is there in a solution, all of them will go and get collected at cathode. All of them will go and they will get collected at cathode. Understood the mechanism? What is happening here? This is impure copper rod. Whatever pure copper stuff is there, no? All the coppers will come into the solution. Again from the solution, all the copper ions are going to the pure copper rod and there the copper is getting deposited. Okay. So if the rod has 100 copper atoms, all the copper atoms first they will come to the solution the moment you pass the electricity. Okay, and from the solution all the coppers are going to the cathode and there it is getting collected. Okay, so that is how you have removed all the pure copper from this particular rod. Yes or no? So gradually the size of anode decreases. What is happening? The size of anode decreases because all the copper is going away. And the size of cathode increases. Why? Because from a solution all the copper is coming and occupying the rod, no? Size of anode decreases, size of cathode increases. This is what you have to observe. Okay? So I have a visual here. So the visual will explain you in detail about how copper comes from anode and how the copper is going again to the cathode. Okay, so understood the mechanism here. This is very important. And this is definitely 2 to 3 mark question for the final examination. Question can be asked in any other way. They just ask you to draw the diagram, or they'll ask you which rod is taken as cathode, which rod is taken as anode, or they'll ask you like what is electrolytic solution, or they may ask you one thing. Okay, say some impurities which are there in this rod, you know, they will also may come to a solution, but they will not go to the cathode and occupy. They will come down at the bottom of a beaker and below the anode rod they get deposited. Okay, and such a deposition we will call it as anode mud. Okay, what is this anode mud? It is nothing but impurities which are present in this rod. Pure copper coming to the solution, again from a solution it is going to the rod and getting deposited. Okay, and some impurities which are there in this rod, they'll come to the solution, they'll go down to the tank, just below the anode they are getting segregated. Okay, so such a stuff we are calling it as anode mud. So anode mud is completely some soluble impurities. Okay, so this is all about electrolytic refining, and now we will see the visual also. See, here is a visual on refining technique of copper. Okay, so we have taken a pure copper rod as cathode and impure copper rod as anode, isn't it? Actually we will take equal size, okay, equal sized rods we will take, but later cathode size will become more and anode size will become less, no? That is why in the visual cathode is fatter and anode is thinner, but initially we will take same size. Okay, so this is a pure copper rod, this is a impure copper rod. Okay, and impure copper rod is connected to a positive terminal of a battery. See, this is a battery and this is a switch. So impure copper rod is connected to a positive terminal of a battery, so this rod is called anode, and pure copper rod is connected to a negative terminal of a battery, and this rod is called cathode. Okay, and it is an electrolytic solution. Copper sulfate solution is taken as an electrolyte, and once it become a solution, Cu plus ions and sulfate ions are separated. Okay, and now actually what happens, from the anode the copper will come to a solution. Okay, it's a impure copper. All the pure copper atoms whichever are there here, all of them will come to a solution. From a solution it will go to the cathode and there it will deposit. That is the reason size of cathode will be more and size of anode will be less. Okay, and one more thing I told you, the impurities, some of the impurities present here will come to a solution and it will get deposited. I told, no, that is called anode mud. Okay, so now let us see the visual how, and these guys, actually this red color dots are nothing but electrons. Okay, so electrons, with the help of electrons only, actually whatever copper is there here, that will come into a solution. Again from a solution it will go to a cathode and deposits. Okay, and now you can see the visual here. See, all the copper is going there, so the rod is becoming fatter and fatter. See, anode mud formation and all, how nicely they have shown. So you can observe once again. Okay, see, copper is deposited, so cathode rod has become fatter. All the copper from this guy came into the solution, so this guy became thinner. Okay, see, the copper went here, so it became fatter. This has lost copper, so it is becoming thinner and thinner, right? So this is the visual on refining of copper. Okay, copper from anode will come to a solution. From a solution all the copper is going to the cathode, so the rod is becoming fatter and fatter. So whatever pure copper, 100% pure copper is nothing but this particular rod. If you take out this rod, that is your pure copper. Okay, so this is how all the purest copper from this rod we are removing. We removed, it came to a solution. From a solution it is going here and segregated. Okay, so this is about refining technique of copper. Okay, fine. And if you like our video, please like it, share it and subscribe for more updates to learn it in a easier way. Okay, so see you everyone and we'll meet in the next video. Thank you.